Quantum computing is nearing a phase of commercialization that may change our world. Early adopters of quantum's unique ability to solve certain types of problems may achieve breakthroughs that enable new business models. Visionary organizations are already aligning with the emerging quantum computing ecosystem to become quantum ready. I would like to invite Dr. J. Ganesh, Digital Transformation Leader, Emphasis, for a tech talk on enterprise transformation with quantum computing and quantum machine learning. Over to you, Mr. Ganesh.
Hello, everyone. Thanks for attending the session. Today, we will discuss an interesting topic of enterprise transformation with quantum computing and all the promise which quantum machine learning brings to the table. My name is Jay, and I head the R&D and innovation for Mphasisat, a group called Mphasisat Labs. Today, we will cover some of these high-level areas. We'll talk about quantum computing, what it is all about, what is all the hype about quantum computing. Why is quantum computing a paradigm shift? What are the application areas of quantum computing and quantum machine learning, which enterprises are adopting? And most importantly, why is quantum an important enabler for enterprise transformation? We will try and cover these topics at a fairly high level of detail, and of course, we can get into any discussions also. Introduction to quantum computing. So if you look at the way computing systems and the technology powering computing systems have evolved, we have come a long way from vacuum tubes to transistors to integrated circuits to microprocessors. Now, we all heard about Moore's law reaching its limit and new and important materials being used to power up future microprocessors. So this is where quantum computing and all the computing power associated with quantum machines provide a lot of hope in terms of changing the paradigm of how we use these systems, changing the way we are programming for the systems, changing the way the systems itself solve problems. So that is where the next leap of computing technology is towards increasing adoption of quantum computing. Now, a few trivia about quantum computing, right? So quantum computing is not easy. Quantum computers are not easy to build and maintain and run because most forms of quantum computers are extremely sensitive to various forms of Earth's magnetism. They need to be maintained at very, very high degree of cooling. Is almost like minus 273 degrees Celsius, absolute zero, and shouldn't be any atmospheric pressure and free from Earth's magnetic field. So you can imagine how difficult it is to build these systems. You need to essentially leverage qubits. So you're looking at qubits rather than bits in the classical computing systems, and you can also see the power provided by qubits. You can solve very, very complex problems at a very, very high speed because that is the power provided by quantum. And we'll talk about why quantum gives you this power to solve some of these complex problems. Now, there are three important properties of quantum computing which you need to keep in mind when thinking about quantum and quantum systems. The first one is superposition, which essentially means that you are essentially able to exist in multiple states. If you look at classical computing, you look at world in typically two ways, is a 0 or 1, right? So classical analogy is that you essentially have 0 or 1. That is how you essentially manipulate in the classical computing system. Again, compare that to that. If you look at quantum systems, they can exist in multiple states, right? And which is an important differentiator. From a classical point of view, it is difficult to imagine this particular concept, but just suspend your imagination and assume that the same, multiple states are possible at the same point of time. The second one is entanglement, which essentially is that two particles, even though they are physically separated by long distance, can operate simultaneously. Basically, these are entangled particles, right? Again, in the traditional world, it is difficult to think of a scenario like this. Imagine one particle in one place and something which is located half a world away, and you still one influences the other without any physical contact, right? So essentially, these two are important concepts in the case of quantum systems, and these are important concepts which we also leverage when we are dealing with quantum systems, both from a hardware and a software perspective. Why is quantum computing a paradigm shift? If you look at quantum computing, they have the power to transform industry value chain, right? Because of all the high power computing possibilities, they have the ability to completely transform value chains. For example, if you look at a domain like logistics, quantum computers can drastically improve the optimization problems faced by logistics. It can help solve completely new use cases which were previously not possible because you needed to deal with extreme complexity in problems and which involve millions of variables to be dealt with, right? So these are very, very complex problems which quantum computing systems provide you the ability and the power to solve some of these problems. Optimization problems are primed for quantum intervention, and that is where maximum number of quantum related use cases are emerging, be it in logistics, in finance, or travel. Optimization of large scale complex problem is a very, very important case study or use case to be solved using quantum systems and quantum computing. Machine learning, there are a number of use cases in machine learning, be it from fraud, risk, multimedia analytics. They're all good use cases and provide an optimal set of variables to be manipulated using qubits. Then we have simulation related problem, be it drug discovery, pharma, modeling, etc., where quantum again plays a very, very important role, and quantum systems are best suited to solve problems of this nature. Some more tidbits about why is it a paradigm shift. Quantum computers, like I said at the beginning, they can manipulate states in multiple options, not just 0 and 1. It can also exist anytime, anywhere between 0 and 1, and of course in multiple states. So this essentially gives you the power to manipulate multiple dimensions which are not possible when you're dealing with classical systems and the classical way of solving a lot of these problems. A quick look at some of the application areas of quantum computing. I spoke about machine learning, optimization, and the simulation as most important problem areas to be solved in using quantum systems. And within some of these things, for example, things like logistic capacity planning. For example, if you are solving a problem for last mile delivery in logistics, or optimizing the route a truck or a car needs to take when you are driving, right? So all these are prime problems because you need to deal with millions of variables, not just the route, but also all the external parameters like climate, temperature, traffic, congestion, etc., etc. These are prime problems to be faced by quantum systems. Dynamic recommendation system, when you're looking at large number of options to choose from and recommend the right option for the user, next best action prediction. These are all prime problems to be solved by quantum systems. Prediction engine, be it in the financial services domain, where you are looking at either identifying the fraudulent transactions or identifying risky transactions, or even multimedia analytics, when you're looking at large language generators, code generators, etc. These are all prime areas for intervention through quantum computing. Like I said, quantum plus AI and machine learning, it becomes a very, very important combination to work on large problems. In our lab, we work extensively in this area, and we have seen that quantum and machine learning built on quantum systems provide several benefits ranging from reduced training time, guaranteed best solution, and most importantly, improved prediction. We've seen exponential improvement in terms of the quality of output we're able to generate through quantum systems by combining the power of machine learning and quantum computing. Now let's look at the last one and the most important aspect of today's discussion, which is about enterprise transformation and quantum computing. What are some of the building blocks of enterprise quantum computing? The first one is that enterprises need to have the relevant platforms and frameworks to work and build on quantum systems. You need to have a great talent base because you need to start early, because we know that this technology is going to hit enterprises 1 or 2 years down the line, and you need to have an internal talent base which is essentially working on this, experimenting, doing POCs, and all the other pilots needed for this. Quantum, selecting the right hardware and software is important. There are various types of quantum systems. You can choose the right one based on the type of problems you're looking at, the use cases you're looking at. You can leverage quantum computing cloud. You don't need to have access to a physical machine. There are several service providers who have launched quantum clouds, and you can leverage any one of these quantum computing clouds. It's like using any of the traditional cloud providers, just that there is a quantum system at the end, which is essentially serving you the models in a much efficient and effective manner. And there are algorithms and models which you need to build, which essentially helps you manage the entire quantum workflow, ranging from easy to deploy and accurate predictions. And these models are where the proof of the pudding is all about in terms of getting the results from the output. And lastly, you need to look at the right use cases, because not all problems are quantum friendly, right? So there are certain problems which are best solved using classical computers, but for quantum computers, there are a number of problems which are right suited. Lastly, when you're starting your journey from a quantum computing perspective, you can start looking at assessments and workshops, because this gives you perspective in terms of what are the right problems to solve from a quantum perspective. You can look at quantum use case through workshops. You can involve the stakeholders and identify the relevant workshops, relevant use cases through the workshops. You can identify the environment setup. These are all stepping blocks in terms of getting to the enterprise transformation story. You need to finally look at the algorithm, which is in the proof of the pudding. You can put a small core team which can work on pilots, POCs, and MVPs. And we've seen this work internally in Mphasis. We have done a lot of these things in terms of starting our quantum journey and progressing in this. And I hope a lot of enterprises benefit out of this approach for enterprise transformation. Thank you.
Thank you, Mr. Ganesh, for sharing knowledge-rich content with our viewers. Ladies and gentlemen, do share the takeaways on social media using the hashtag ETHRNexTech.